Anyway, today in physics, we're going to be learning about acceleration, we're going to be learning solution methodology, and we're going to be doing drop problems. We're going to start thinking about drop problems and how to do it in your head. This will change how you think. It makes you smarter. It's not very easy to do. These are things that make you smarter, though, the more challenging things. You'll find after you work it a little bit, you can get pretty good at it. And the moment you start realizing it's kind of fun, you are off and running. That's what physics is. The reason people do physics, it's fun. This is a neat way to think. So let's start out. We want to talk about an acceleration, all right? An acceleration, all right? We start off with, let's say we have a car, and it's originally moving at 20 meters per second, and it goes from 20 meters per second to 30 meters per second. Okay, well, what's its change in velocity? Well, we know change in velocity is not a thing you have to memorize. Change in velocity, rather. Change in velocity is simply, well, what? How would you find change in velocity here? Think about it. You were going 20, now you're going 30. How much did you change? You know you changed your velocity 10 meters per second. But how did you get that? Well, you realize that you took 30 and subtracted 20. Well, what's 30? 30 is your final velocity, 20 is your initial velocity. Therefore, the formula for change in velocity must be final velocity minus initial velocity. Or 30 meters per second minus 20 meters per second equals 10 meters per second. Awesome! It's not acceleration. That's a change in velocity. But that change in velocity took place over a specific unit of time, over a specific time interval. Let's say it took you 5 seconds to change that velocity. Well now, the formula for acceleration is your change in velocity over time. What is that going to come out to be? Well, we know the change in velocity is 10 meters per second, and the time unit that took place in, what did I say? 5 seconds? I hope I said 5 seconds. 5 seconds. Well, what does that come out to be? Well, we know 10 divided by 5 equals 2. That is unsatisfactory, though, because we have to consider the units. If you're driving in a car and you're changing, say from 20 miles an hour to 30 miles an hour, you changed by 10 miles an hour. And if you did that in 5 seconds, that means every second you changed by 2 miles an hour per second. So 2 miles an hour is your velocity change per second. Well, miles per hour per second. Okay, that's not a problem. It shows how much you changed your velocity every single second. But when I'm using meters per second and then I'm dividing that by seconds, you can see we have to accommodate that it's meters per second per second. Let's just look at that. A meter per second per second. If you remember in math, you might have learned invert and multiply. Well, second is really second over 1. So if we invert and multiply, it's 1 over second. That equals meters. Second times second is seconds squared. What's that, you say? How come we invert and multiply? What? Nobody ever told you how come we invert and multiply? Check it out. The reason we invert and multiply is pretty straightforward. I'm trying to get rid of seconds over 1 here. So how do I get rid of seconds over 1 here? Yeah, it's not very hard. Multiply by its reciprocal, 1 over second, and everything cancels out. But whatever I do to the bottom, I also have to do to the top. So I have to then multiply the top by 1 over second. You see that? No magic steps, no math trickery. It's just whatever you do on the bottom, you do to the top too. All right, so this really makes sense. That's meters per second squared. This is the unit of acceleration we use in physics, meters per second squared. Meters per second, that's a velocity. But meters per second, or meters per second squared, there's your acceleration, okay? So when we solve all this, then we get 2 meters per second squared. That would be your acceleration. Woohoo! Okay, so we have an idea of how to do this, but now I want to show you how we do it in the big kid way that we do in physics. This is the way you solve every physics problem from now on, mostly. There are times that we're not going to be using this method, but it's only because we are so good at this method, and there are certain times this method becomes cumbersome. By cumbersome, I mean you don't solve the problem as easily or as effectively. But if you are doing something you don't know how to do, use this method. It'll guide you. It'll always guide you. This is a really useful method to use across the science spectrum. Okay? Follow along. We start with a word problem. Physics, generally, like many math questions, start with word problems. So, Tim is driving at 32 meters per second, and 5 seconds later is at 20 meters per second. What was his acceleration? Word problem. Word problems are sort of obnoxious. So first thing we do is get rid of the word problem, and we do it this way. In physics, you do it exactly this way. You write neatly, you write big. Take up a lot of paper when you're doing this. Please don't do little writing. Little writing, very often you will confuse things and you'll get the problem wrong for the very worst of reasons, that instead of 32 it looked like a 36 or a 38. That's not a good reason to get it wrong, so write big. So you write this first, okay? You write the word givens. Capital G, Ivens, underline it, make it clear. So now we extract the data. Tim's driving at 32 meters per second. What is that? That is my v sub I. That is my initial velocity. We make a nice equal sign, and then we write 32, and now, meters over seconds. We never use a diagonal line. Why? Because if you use a diagonal line, you might confuse what's on the top and what's on the bottom. It's easy to do with a diagonal line. It's virtually impossible to do with a horizontal line. So you always use a horizontal line. We keep this stuff neat because we have work to do with those units. My v sub f, might as well group them together, is 20 meters per second. Notice the clarity with which I write. I don't care if you have pig scratch the rest of your life. When you're doing physics problems, write them nice and neat. That's important. The time it took place on was 5 seconds. We know that the formula for delta V is VF minus VI. All right, so you might want to write that there. It's useful. And we are looking for acceleration. Okay. The next step, you write formula. After you write it once and you know what it stands for, you can change it to form, because that's legitimate. It's the form of the equation that we're going to be using. And in this case, acceleration, if you look in your reference tables, it's the second, on page 6 in mechanics, it's the second formula. So acceleration is change in velocity over time. Expand that, so acceleration equals VF minus VI over time. Again, notice everything is written very, very neatly. Don't mess your problems up because of unneat writing. This is the place to take your time to write carefully. And by the way, please use pencil. Using pen is not really what you want to do here. We all make mistakes. You use a pencil, you use an eraser, you fix your mistakes when you see them. Please, physics humbles all of us. Substitution and solution. You substitute the numbers and their units into the problem, and then you solve it. From now on, you don't have to write substitution and solution. You can write S and S. But please know what it stands for, substitution and solution. So we rewrite the formula. That is an important step. Whatever you've solved this formula to, sometimes you'll have to do a lot of algebra on this formula. You might have to solve this for VI, and you're going to algebraically solve this before you ever put numbers in. Again, that's an important step. So acceleration equals VF minus VI over t. This keeps it clear. And now we substitute the numbers in. VF is 20 meters per second minus 32 meters per second, which is my VI. Put those in parentheses, so you remember you want to solve that first, and then you're dividing it by time, which in this case is 5 seconds. Now, and only now, are you ready to do it in your calculator? So, 20 minus 32 equals, that's a negative 12 meters per second over 5 seconds. So divide by 5 equals negative 2.4, and that's going to be meters per second, or meters per second squared. The acceleration is negative. That means Tim is slowing down, right? He was going 32 meters per second. 5 seconds later, he's slower. So he has a negative acceleration. How do you know an acceleration is negative? Well, if you're driving in a car and you have a coffee cup and you place the coffee cup on the dashboard and you accelerate forward, right? You're going from 0 and you're starting to go faster and faster. You're accelerating forward. Which way is the coffee cup tending to fall? Backwards. So if the coffee cup falls backwards, which way is your acceleration? Forwards. In this case, he's doing 32 meters per second and slowing down at 20 meters per second. If you're in the car and you hit the brakes, which way is your coffee cup likely to fall? Forward. So which way must your acceleration be? Backward. So is it possible to have a forward velocity and a backward acceleration? Yeah, that's what we call braking or deceleration. But in physics, we'll call it a negative acceleration. And just whichever way the coffee cup wants to fall, you're accelerating the opposite way. We'll be talking more about that. In any case, this is how we solve physics problems. It's extremely powerful. You'll realize if you look at your reference tables, there's lots and lots of formulas. We do it all this way. Now, it might take you a little bit to get used to this, but look at all the formulas and all the different things we're going to be studying all year. This is pretty much how we do everything. So get used to this, get good at it. It's really worthwhile. That is acceleration and solution methodology. I'll get back to you in the next video.